In this video, we're going to look at question number 8 from our test review. In this question, we're asked to verify these identities. So my first identity, 1 over 1 plus cosine x minus 1 over 1 minus cosine x equals negative 2 cosecant x cotangent x. Remember, when we're doing verifying identities, what I would like for you to do is put up a wall underneath that equal sign. We're trying to show that the two sides here are equal to each other, so we can't be moving things from one side to the other. You can work on either side, and we just want to work until we get them to look the same. So I'm going to start on the right side, and I know that I can change cosecant to be 1 over sine x, and I can change cotangent x to be cosine x over sine x. And we're multiplying all of these together. So negative 2 times 1 times cosine x would just be negative 2 cosine x over sine times sine, which would be sine squared x. And that really seems to be all I can do on that side. So let's go to the left side. Over here I've got two fractions, and what we need to do is get a common denominator. So I'm going to multiply 1 minus cosine x times the first fraction, and I'm going to get 1 minus cosine x over 1 plus cosine x times 1 minus cosine x minus, and then I'm going to do the same. I'm going to multiply 1 plus cosine x times the fraction on the left. So I have 1 plus cosine x over 1 plus cosine x times 1 minus cosine x. Okay, now I have a common denominator. So we're going to combine these into one fraction. On the top, this minus sign right here has to be distributed to both parts in the numerator of that second fraction, which means when I rewrite this, I'm going to have 1 minus cosine x from the first fraction minus 1 minus cosine x, because this is going to go to the 1 and also to the cosine. Now in my denominator, I'm going to multiply this out. 1 plus cosine x times 1 minus cosine x, that's going to give me 1 minus cosine squared x. It's a difference of squares in factored form in our first step there, and so I've just multiplied it out to be a difference of squares. So now in my numerator, I see that I have 1 minus 1, so those can subtract away, and then I have negative cosine x and another negative cosine x. That gives me negative 2 cosine x, and so that's nice. Now my numerators are matching, but what about the denominator? Well, I have 1 minus cosine squared x, and I know that cosine squared x plus sine squared x equals 1. So 1 minus cosine squared x would be equal to sine squared x, and there we have it. Now that is one way to work this identity. There are other ways that you could arrive at this answer, and that's always true with identities. There might be other methods. I'm just showing you one way to get there. Let's look at the next one. This is a great example of an identity that has a variety of methods you could use to verify. First thing I'm going to do is put up my wall there, no moving things from side to side. This time I think I'm going to start over on the left. And what a lot of people like to do is change things and get them in terms of sine and cosine, and you could do that here, but there's actually a faster route. If you notice, I've got two terms here, and they both have a tangent. So I'm going to factor out a tangent x, and if I do that, I'm left with secant squared x minus tangent squared x. So I factored out that tangent x, and what's left there inside the parentheses, notice they both have squares, and typically when you see squares, it's a good sign that you should check your Pythagorean identities. we have a Pythagorean identity that says 1 plus tangent squared x is equal to secant squared x. And so that means that secant squared x minus tangent squared x would be equal to 1. And so I can change that to 1, and of course it's still times tangent x. So on this side I've got tangent x. At this point I think I'm going to switch over to the other side, and let's see if we can do something with this. Secant x is equal to 1 over cosine x, and cosecant x is equal to 1 over sine x. So now I've got two fractions that are being divided, and to divide fractions we multiply by the reciprocal. So I'm going to keep 1 over cosine x times, and I'm going to do the reciprocal of the other one and make it sine x over 1. And so if we multiply those two fractions together, we get sine x over cosine x, which of course is equal to tangent x. And now my two sides are the same. Let's look at one more identity. Here we have cosine of 3 pi over 2 plus x equal to sine x. First thing that I notice here is this 3 pi over 2 plus x. So I've got two angles being added together. I think a good identity is going to be our sum identity for cosine. So I'm going to put up our wall here. There we go. And let's use this sum identity for cosine. When I use that identity, 3 pi over 2 is going to be my A, x is going to be the B. So I'm going to get cosine of A, which is 3 pi over 2, times cosine of B, which is x, minus sine of A, so sine of 3 pi over 2, times sine of B, or in our case, sine of x. Now that I've done this, we want to substitute in unit circle values for cosine 3 pi over 2 and sine 3 pi over 2. So 3 pi over 2, that's the negative y-axis, and so cosine is going to be 0. So I get 0 times cosine x minus sine of 3 pi over 2, it's going to be negative 1 times sine x. So 0 times cosine x, that's just 0. And then I have minus a negative 1 times sine. So the minus times the negative is going to make it positive sine x. And now both sides are the same.